In this video, we're looking at maximum flow and minimum cut, a bit more quick fire. We're assuming that you know the process, you just need to be reminded of it. So first step, we haven't been asked to, but let's label our source and our sink. The source is where the water supply is coming from. In this case, we can see all the arrows leading out of A. Therefore, the source is A. Sometimes it's not as obvious. It might not be A, it might be L, and this A might be in the center, for instance. Where's our sink? Well, the sink is where everything is flowing to, i.e. the sink. So we can see all the arrows seem to be going into I. Therefore, I is our sink. Our next step is to find our maximum flow using our systematic approach. That means we're working top to bottom. We need to account for our entire capacity. Starting at A, find the top branch out of this network here. So we can see A to B, B to G, and the top branch, G to H, H to I. Write that out, A, B, G, H, I, and then account for the smallest pipe, which is our bottleneck. In this case, it's BG, which is 280. Now, we've accounted for 280, maybe it's litres a minute, take out 280 from the rest. Now, we move on to the next path in which water can get from the source to the sink. We can keep using A to B, right? But then you may note that B to G is now busted, so we can't use A to B anymore. It's essentially 120 litres oversized. We go A to D, D to F, F to G, G to H, H to I. The maximum amount of fluid we can push through is 50, limited by pipe FG. Write down a network A, D, F, G, H, I, maximum 50. Deduct 50 from each one. We're finished. Let's look at our next route. So in this case, highlight A to D, D to F. We can't use F to G anymore as it's busted. So F to H, H to I. Write out this route. What's the maximum capacity? 50, 50. Deduct 50 from each pipe in this route. Next step is to find the next path. A to D is still used, 200 left, can't go to D to F, D to E. Top to bottom. Maximum route, 200, 200, 150, 150, 150, so it's 150, right out route. Deduct 150 from each value, for each pipe. Next step, find the next pipe, top to bottom. Maximum 50, 50, 150. 50 is the max we can push through. Deduct 50 off. A to D is now busted. Most we can push through this, AEI, is 100. Deduct off. Now we've completed our network systematically. Let's calculate our maximum flow, as there's no more ways of going from A, the source, to I, the sink, as look, busted that way, busted that way, busted that way. Next step, sum up, find max flow. All zeros, 8, 5, 10, 15, 23. Carry the 2. 2, 4, 2, 4, 5, 6. Context of question, 630 watt. Doesn't give it. Could be kiloliters a minute. Not sure. Just an idea. So always put the context of the question. In this case, it's 630 units. So max flow. Let's confirm with minimum cut. Minimum cut is where you cut the network and cut the source from the sink so there's no water flow from source to sink. To do so, highlight dodgy paths. Dodgy pipes are pipes with no reserve left. Minimum cut is finding 630 using a cut. If we can cut from the source to the sink by severing pipes that have been completely used up, we've found the minimum cut, which is our maximum flow, which is 630. As we can see, if we cut this pipe, no water can flow from A to I. Therefore, let's cut this. Let's call it cut 1. And let's add these together. 150 plus 530 is 680. We found our minimum cut, which is our max flow. Just to compare, if I look at this over here, let's call that cut 2. If I add them up, 400, 700, 800. If you have not found your minimum cut, the value will be larger. See how this 800 is not the minimum cut value because we have 680 over here. Okay, so this is the end of our video. We've looked at how to find the maximum flow and also confirm with the minimum cut.